Here is our Fruity Freeze example, and we're doing the conclusion for that, for our level 2 simulation. So here is the information that we need to give it. So we need to use our results to write a conclusion for telling Grace the mean number of Fruity Freezes that she will buy and the chance of winning the mover ticket. So that's the first and foremost. After that, we need to talk about sampling variability. So that is talking about that sentence data if I did another simulation. What do we think would happen? We need to talk about at least 2 of the assumptions, identify them, and we've got to discuss the effect that those assumptions may have on the simulation. We want to think about other variables, and we want to think about possible improvements that we could come up with and find. Okay, so first of all, here I've just got the data quickly on the side there. The key results that we want to look for is we are looking for that mean, and we are looking for that probability of winning. So those are our 2 results that we want to interpret first of all. So all we want to say is the mean number of Fruity Freezes that Grace will buy is 8.68. And we also want to say that the probability of winning a movie ticket is 21 out of 50. So that's the first part, answering the investigation question. Okay, so that's that part done. Okay, now we want to think about sampling variability. So let's think about the graph particularly. If you were to do another simulation, do you think that you would get the data values that look exactly like the ones that we've got here? Do you think that you would have data that looks exactly like this and exactly these numbers of values? The answer is probably no. Okay, so we know we're going to get different data. Okay, because every time you do a new simulation, we're going to get different results. Then I want you to think about that mean. Do you think the mean is likely to be exactly the same, similar, or completely different? And I know that in this case, we've got a mean of 8.68. If we took another sample, we know that that mean is going to move around a little bit. Okay, so our mean's about here. So we know that that mean, think about your confidence interval, would move around a little bit. It's not going to move around a lot, but it may change. Okay, so that would vary a little. Then the third part of it is looking at your overall conclusion. Do we expect that our probability here of 21 out of 50, do you think that that probability would be exactly the same, similar, or quite different? And again, similar to the mean, I would expect that my probability would be similar. I don't think it's going to be exactly the same. Okay, if I did another simulation with 50 trials, I might get 22 yeses, or 20, or 18, or 25, but I'm going to get a number somewhere similar to the one that I've found there. So that's what we want to be able to say here, is if I did another simulation for Grace's Fruity Freeze ice blocks. It's got to be in context. And then I'm going to leave this you to actually fill this in yourself, because I want you to talk about what would happen with the data, what would happen with the mean, and what would happen with the probability. Okay, so that's that section of it. All right, So discussion of sampling variability. This next part, the assumptions, that is one of the critical parts now if we're looking for a merit or an excellence, is to think about what's the difference between the simulation that we set up, what do we assume, and what are some of the variations between that and real life. Okay, so let's think about in terms of assumptions. There's an assumption that we always have, no matter what we do, we always assume independence. Okay, so let's think about what it is that we're assuming independence of. So if I was to go into the dairy to buy myself this Fruity Freeze ice block, then as I go in, I would be getting the chance that I get an apple symbol, a grape symbol, a strawberry symbol, etc. I would assume that each time I go in to purchase it, each ice block is independent. All right, so that's what we're assuming, the independence. We're assuming that each ice block is independent, and therefore what symbol it has is independent. Okay, so that's one thing that I'm looking for. Another assumption is always looking at our probability, and we expect our probability to be constant. So that means if I go into the shop and I was to buy an ice block, that I expect the chance of getting an apple symbol, a pineapple symbol, a grape symbol, or a strawberry, that I'm assuming that those are going to be the same probability no matter which ice block I buy. Okay, so I expect it's the same probability for every ice block bought. Okay, now this in reality may or may not be true. So in reality, if I think about what happens in real life now, then if you think about in terms of in the factory where they're actually making this, okay, they will have a production line. And so in their production line, they will have people making ice blocks. Okay, and then they put all of those ice blocks together in a box. Okay, so when you're making these in a production line, it would be easiest to have a stamp that stamped all of the ice blocks with the same symbol. And then after a while you change it and do it a new symbol. And then after that, change it, do a new symbol. So that means, that would mean, if that's the case, that each of these symbols might happen to all have the strawberry symbol on them. Okay, simply because of the way that they were produced. And so if that's true, then that means this probability here does not hold in real life. Okay, so what does that mean? What effect does that have? Well, that means that my simulation results are not completely reliable. I can't completely trust those results. That my mean or my probability might be different. Okay? That my shape might be different. All of those things could vary. All right? Because they're giving us a good estimate, but because there may be some issues, it may not actually happen in real life. So those are some of the things that I want to think about. I can also think about any other difference between what happens in real life and what happens in my simulation model. Okay? And so I'm not going to go into too much more detail because I want you to actually think of some of these assumptions for yourself. All right? So that would be identifying two assumptions and discussing the effect that would have. Then I want to think about what are other variables I need to consider. So again, this is going back to that real life and thinking, well, maybe Grace gets more money. Okay, maybe her grandparents came over and gave her some money to buy an ice block, so she was actually able to buy 11 ice blocks rather than 10. Maybe she lost some of her money. So maybe she can't buy all 10 ice blocks. All right, so that's thinking about in terms of that number of ice blocks that she could buy. In real life, it could be ice cream, ice blocks. Could be more or less than we expected. So there's all sorts of other real life issues that we could talk about there. So those are some of the other variables. Last but not least is thinking about suggestions for possible improvements. So that if we were to do the simulation again, how would you improve it? So one thing that certainly springs to my mind is thinking about my sample size. If I have a bigger sample size, then that would give me more data, more information, a better estimate of the variation and a better estimate of the mean. So that's one thing that I would choose to do, is to increase my sample size. And so on. So those are the kinds of things I want you to think about. So if we have a look at our marking schedule, to get through to the achieved, you need to be able to answer the investigation. So that's either telling me what the mean is or telling me what the probability is, and it needs to be a sentence in context. Not just saying the probability is 21 out of 50. The probability of Grace winning a movie ticket is 21 out of 50. For my merit, you need to show me that you understand that the results are estimates. Okay, so being able to talk about somewhere along the line that, look, this is a good estimate of what's happening, but it is a simulation. It's not a population that I'm collecting data from. I need to talk about that sampling variability, and again, in context. If you just say, if I did another simulation, I'd get the similar data, that's not going to be enough. It has to be in context. That the number of ice blocks Grace would buy is ... And I need one assumption discussed for merit. For my excellence, I want to see statistical insight. So that could be talking about improvements, could be talking about limitations, could be a number of other things in there. I need to talk about my second assumption. I need to discuss that. And I need to look at the effect of at least two of those assumptions has been explained. All right, and then that is my entire investigation.